Welcome back to the Exploit HQ and to part 2 of our beginner series on web application security. Just like last time, you need zero experience to follow along. In part 1, we changed a number and saw a stranger's shopping cart. Today we do something that feels almost magical and a little scary. We are going to make a website hand us files from deep inside its own computer, files it was never meant to show anyone. First, the plain words. Many web pages are not one single file. To build one page, the app quietly loads several smaller files and stitches them together. The app decides which file to load, and very often the file's name is sitting right there in the web address, after the letters PAGE and an equals sign. That little setting is meant to load the app's own pages. But if the app trusts whatever name we put there, then we, the visitor, get to choose the file. And that is the whole problem. This flaw comes in a few flavors, and the names sound scarier than they are. LFI, local file inclusion, means we read a file that already lives on that same computer. RFI, remote file inclusion, is the nastier cousin, where the app loads a file from somewhere else on the internet, even one the attacker controls. And path traversal is the trick we use to move around the disk. Those two little dots and a slash, // simply mean go up one folder, exactly like the back button in a file browser. Do it enough times, and you reach the very top of the disk. You might be thinking, so what? It is just a file. Here is why it matters. The same trick can read the server's list of user accounts, its configuration files, which very often contain database passwords in plain text, and the app's own private source code. And in the worst case, remote file inclusion, the server can be fooled into running an attacker's code, which is a complete takeover. This family is tracked by the security world as path traversal, CWE22, and file inclusion, CWE98, and it lands inside OWASP's #1 category, broken access control, the very same top category from part 1. For the demo, we will use our own local practice app, and just 3 simple tools. Curl is that small program from part 1 that sends a web request straight from the terminal, like a browser with no window. Cookies.txt is a file holding our logged-in session for our own practice app. Think of it as the wristband from part 1 that proves we are allowed in. And grep is a tiny helper that reads a big pile of text and keeps only the lines we ask for, so the answer is easy to read. Our practice target is DVWA, the damn vulnerable web application, running only on our own machine. It has a page whose whole job is file inclusion. Let's break down that page's address before we touch it. So 127.0.0.1 is our own computer, nobody else's. The FI page is built for file inclusion practice, and that page equals part is where the app expects the name of one of its own pages. The flaw is that it never checks, so we can quietly ask for a completely different file instead. Let's break down the actual command we'll run, piece by piece. In plain terms, we prove we are logged in with our wristband. Then we ask the page to load the file called etc passwd, which is the computer's own list of user accounts. Then grep tidies the answer down to the interesting lines. Let's open the terminal and type it together. Type it with me slowly. Look at that. Those are real user accounts from inside the server. Root is the all-powerful administrator. www-data is the account that runs the website. MySQL is the database account. This is the etc passwd file, a file that is supposed to stay on the server, out of sight. The page was only meant to load its own pages, yet it happily read a private system file just because we asked. Now in that first command we handed over a full exact path, but often an app only lets us pick from its own folder. So how do we escape that folder? We climb, using .. Each .. steps us up one folder toward the top of the disk. We add a few extra just to be sure we reach the very top, and then we walk down into etc. passwd. Extra climbs at the top do no harm, you simply cannot go higher than the top. Type it with me. Here we go. The exact same secret file, but this time we reached it by climbing folders with .. instead of typing the full path. That climbing move is what the word path traversal means. And remember the scariest cousin, remote file inclusion. If the server allowed it, that page equals part could point at a file on the attacker's own website, and the server would fetch and run it. We will not demo that one because it needs a second machine, but it is the very same root cause, an app trusting a file name it should never trust. So how do you find this flaw, and how is it fixed? To find it, you do exactly what we did. Put a path where the app expects a page name, try climbing with .. or a full path, and see if a file you should not get comes back. To fix it, the golden rule is, never feed a visitor's text straight into a command that opens or includes a file. Instead, keep a short allow list of the exact pages that are permitted, reject everything else, and switch off the setting that lets the app load files from the internet. That closes the whole hole. And one rule every single time. Only ever test apps you own or have clear written permission to test. Our DVWA runs only on our own machine, and it was built for exactly this kind of safe, legal practice. In Part 3, we will look at information disclosure, all the little ways an app leaks secrets it never meant to. Thanks for learning with the Exploit HQ, and I'll see you there.